Assalamu alaikum. Welcome to the next lecture. In this lecture, we will be discussing more in detail tariff, that, or in other words, electricity tariff. As we know, the rate at which electrical energy is supplied to the consumer is known as tariff, or in general, electrical tariff. Because tariff is a general term, it can be used for any, uh, we can say, commodity, like we have communication, like we have other things that we usually bought from the companies. Although tariff should include the total cost of producing and supplying the electrical energy plus the profit, yet it cannot be same for all types of consumers. As a general rule, whenever this tariff is uh, calculated, it should usually have total cost producing, supplying the electrical energy and plus profit included in it. But usually you will see it has a different form for different consumers. So this is because the cost of producing the electrical energy depends on to a considerable extent upon the magnitude of electrical energy consumed by the user and his load conditions. So as per the requirement of the electrical energy by the consumer and the load condition, it has to vary because it cannot be kept same for every consumer. Like we have domestic consumers, like we have commercial consumers, like we have industrial consumers, their amount of load is different and their profile of load is different. So as per the amount of load and profile of load is there, so electrical tariff will be different. You'll see in this picture. Therefore, in all fairness, due consideration has to be given to different types of consumers like industrial, domestic, commercial while fixing the tariff. So it makes a little bit uh, complications in the tariff because for design different tariff for different consumers, it makes it a little bit complicated. But whether it is complicated or not, it has to be done. So let us come to the generalized form of the tariff, how the tariff is usually calculated, how it is described. It is usually described in the form of equation, that is A is equal to Cx plus dy plus F, where A is the total amount of bill for a certain period for a consumer. Let us say it is 1 month. X is the maximum demand during the period. So maximum demand has to be measured for the consumer, and let us say this maximum demand for this period is X. And Y is the total energy consumed during this period. Definitely maximum demand may be calculated or measured in terms of kilowatt or kVA. So maximum energy consumed will be measured in kilowatt hour, and 1 kilowatt hour is one electrical unit. And C, unit charge for maximum demand, that is rupees per kilowatt or rupees per kVA, is this C. When you multiply C and X, you will get the amount of rupees, because C is the unit charge per kilowatt and X is the maximum demand. So D is the unit cost of energy, rupees per kilowatt hour, and F is the fixed or constant charges. It is the cost of metering equipment and meter reading. Usually for meter reader, he has to be paid to read the meter every month. So that has to be included in this generalized form of tariff, that is F. But you will see that it is not always there in every form of the tariff. So there are usually 6 types of tariff. One is flat demand rate, another is flat rate tariff or straight meter rate, another is block rate tariff or block meter rate, another is two-part tariff or Hopkinson demand rate, another is three-part tariff or Doherty rate, and the last one is power factor tariff. So these are different types of tariff that we usually use to charge the different types of consumers. So coming to the first one, it is the flat demand tariff. Usually it is expressed as A is equal to Cx, that is the bill depends only on the maximum demand irrespective of the amount of energy consumed. This is the oldest form of the tariff that was used by different utilities. Today you will only see it in those parts of the world where you can say where which are very underdeveloped and which are very poor. Usually you will also see it almost every part of the Kashmir. This is flat demand rate, flat demand tariff. We are usually charged on the basis of maximum demand, and we assume that our maximum demand is 0.5 kilowatt or 1 kilowatt. As per that, the tariff is charged, the consumer is charged on the basis of maximum demand. So whatever be the energy consumption is, it is not taken into consideration. Only the maximum demand is taken into consideration. The charge is made on the basis of total load installed, whatever be the total load installed. But here in our Kashmir, it is not the case. We usually have a load of 10 to 15 kilowatt, and the agreement, or we can say the tariff that we, or we can say the charge that we pay only for zero point 0.5 or 1 kilowatt. Here also, the cost of metering equipment and the meter reading is not installed. So usually in the metropolitan city, you will not see such type of tariff, but it is also about a part of tariff which is usually used uh, in, you can say, in the villages or in the far-flung areas where the load is not as much as in the metropolitan cities. So another one is the flat rate tariff or straight meter rate. So it is expressed as A is equal to dy. The charge depends only on the energy consumed. This tariff is usually used in domestic and commercial consumers. So here the advantage is that whatever the amount of energy you will be using, will be charged as per the energy usage. But the problem is that if somebody is not using any energy, so even if you have spent or utility has spent a definite expenditure to serve the customer, like meter reader, or the other things, that means they have uh, expend a lot of money in delivering the electricity up to that, this or making the infrastructure to supply the electricity to that customer, but that customer is not using any energy. In that case, it is a disadvantage for the utility. So it also does not encourage the use of electricity. In other words, it may be discouraging the electricity, because the more you are using the electricity, the more you will be charged. So there may be some other type of tariff which may encourage the customer for usage of the electricity. That is done by the block rate tariff or block meter rate. It charges the customer on the sliding scale. A certain unit is for a certain block of energy, and for each succeeding block of energy, the corresponding unit charge decrease or increase depending on the availability of the power. For example, if somebody has used 1,000 units of the electricity, the first 200 units may be charged or maybe free of cost. Another 200 units may be charged for 2 rupees per unit. Another 200 maybe 4 rupees per unit. And as the blocks are made of 200 units, you can see, as I've given you the example, the amount of rate, or we can say the unit charge, has increased. So in this case, we can say this is the block rate tariff. In this case, we are trying to discourage the customer to use the electricity. And this is the case where there is a scarcity of the electricity, or we can say where the load is more as compared to the generation. In that case, we want that the customer should be discouraged to use more and more power. But in some countries, the energy supply, or we can say generation, is more than that of the demand. So in those countries, the sliding scale, or we can say the block rate tariff, is made in such a way that the first blocks are charged for higher units, and the other charge, that is the higher units, are charged uh, for less rupees. In the previous case that I told you that the first 200 are free of cost, the next 200 of 2 rupees per unit. Here may be other way around. The first 200 may be of 4 rupees. The next 200 may be for uh, 2 rupees. The next 200 may be of 1 rupee, and next 200 may be free of cost, depending upon what type of the tariff is there. So I will show you one of the examples in this case also. So how this is usually done, and how a customer is usually charged on the basis of block rate tariff. So we may have another one that is a two-part tariff. It's also known as Hopkinson demand rate. In this case, the tariff is expressed as A is equal to Cx plus dy. As you can see in this equation, we have x and y. That means here the maximum demand is also charged as well as the energy consumed is also charged. So here there is the two disadvantages that uh, were present in case of you can say flat demand rate and straight meter rate. So they have been partly, we can say somehow they have been eliminated in this two-part tariff. So but there is a problem in this. You have to first a utility have to first can say measure the maximum demand of the consumer. So this is usually used for medium and large industrial consumers, and you will not see particularly this for domestic consumers, even for the commercial consumers, because for domestic and commercial consumers they have usually heating and lighting loads, but in case of industrial load they have mostly motor loads. So they have both this maximum demand as well as this energy demand. They are both charged. Now one more is the three-part tariff or the royalty rate. This is also used for the large industries. So for them, this is the only tariff which exactly gets the expenditure incurred by the supply authority on the consumer under all conditions of the load. So this is expressed as A is equal to Cx plus dy plus F. Apart from the uh, this maximum demand charges and energy charges, the consumer is also charged for the fixed, or consumer is also giving some fixed charges. So these fixed charges are for the meeting equipment and this meeting services. So this is usually used for a large industrial consumers. And the last one is the power factor tariff. As we know, for a maximum demand, a consumer having low power factor will be drawing more current than the consumer having the high power factor. Maybe they have the same maximum demand, but the consumer having the low power factor will be drawing more this current. And when it is drawing more current, the utility has to supply, or the utility has to provide the equipment which can bear that more current. So in that case, the capacity requirement of the generation, transmission, and distribution equipment for the former having a low power factor will be more as compared to the later. So the equipment rating we can say will have to be more in case of low power factor for the same maximum demand. So if such consumer is charged for the maximum demand of kilowatt, the utility uh, maybe we can say at the loss, or we can say have not that much of the profit because it has to invest more on the requirement generation, transmission, and distribution equipments. So what it does, it does the power factor. It, it tries to uh, somehow involve the power factor. So how does it do that? It will do by using the KVA maximum demand tariff. Actually, the demand tariff that we have in a two-part tariff, as I have told you that it can be kVA or kilowatt. But when kVA is taken, when kVA is charged, it can take care of the power factor itself. So this is also a two-part tariff, except that the maximum demand in kVA is charged instead of kilowatt. In the two-part tariff here, this X is the maximum kilowatt, but in case of power factor tariff, this X is replaced by the kVA, or we can say maximum demand in kVA instead of maximum demand in kilowatt. So it takes care of our factor itself. Or if a kilowatt is charged and if we charge kVAR separately, both are charged separately, then also this power factor is also taken care of. So the consumer is charged not only for kilowatt but also for kVAR. It should be kVAR, thereby taking care of power factor as well. So In this case, when such instance will occur, the consumer will try to improve the power factor so that this will be, when it tries to improve the power factor, this will reduce. That means the kVAR requirement by this consumer, or the kVAR that is supplied by the utility, will be less, and hence the rate, the charges for the consumer will be reduced when you improve the power factor. One is the sliding scale tariff, that is the block rate tariff, as I have discussed earlier. For the general block rate tariff, it will be similar to that of this block rate tariff. So here I need not to explain this. This is similar. The first blocks will be charged differently, second blocks will be charged differently, and then the other charge will be charged differently, and so on. This is similar to that of this, but only thing is this is also applicable to the power factor tariff. Now these are all about the different types of tariff that we have. This also is usually used for the large or medium scale industrial consumers, because for them you'll see the power factor will be slightly lesser as compared to the, or we can say power factor will come into picture. As I told you in one of the classes, that in case of heating and lighting load, we take the power factor close to 0.5, 0.95 or 1. So in that case, we can say the power factor will not play much role. But in case of motors and in case of this motor loads, industrial consumers, which have mainly the motor loads, power factor plays a vital role. So we have to take care of the power factor in the industrial consumers. So let us try to do one example based on the tariff. The monthly electricity consumption of a residence can be approximated as: its light load is 5 tube lights, 40 watt each, working for 3 hours daily. Fan load is 3 fans, 100 watt each, working for 5 hours daily. Refrigerator load is 1 kilowatt hour daily. It consumes this much of energy daily. And other miscellaneous load 1 kilowatt for 1 hour daily. So how this is charged usually like this: first 15 units 2.74 per kilowatt hour, the next 25 units 2.70 per kilowatt hour. You can see that it is decreasing. So in this case, since the rate is decreasing, it encourages the use of this energy or use of power. Remaining units, apart from these 40 units, it is 2.32 units per kilowatt hour. Constant charge, that's F, that we have used in our equation, generalized form of tariff, that's F, that is 7 rupees 7 per month. And discount for prompt payment, if the payment is done before due date, there will be a discount of 5%. So you can see, since it is has to be done for 1 month, so total energy consumption in 30 days will be, first we'll calculate the total watts. It will be 5 into 40 into 3 hours, that means it will be watt hour. When we divide it by 1000, it will be kilowatt hour. That means 5 into 40 is the total number of watts multiplied by hours, total number of watt hours, and in 30 days multiplied by 30, when you divide by 1000, it comes out to be 30 kilowatt. That will be equal to 18 kilowatt. Similarly for the fan load, so 3 fans of 100 watt each, that means 3 into 10, 5 hours daily, that means multiplied by 5, it will be watt hour. When you divide it by 1000, it comes out to be kilowatt hour. So this comes out to be 45 kilowatts. So this is already in the energy. So for 30 days it will be 1 into 30, that comes out to be 30. So this miscellaneous load 1 kilowatt for 1 hour. So 1 into 1, when you convert into kilowatt hour, it will be 1 kilowatt hour daily multiplied by 30, it is also equal to 30. So total it will be equal to 30 plus 30 plus 45 plus 18, 123 units. So total charge, that means it will be the fixed charge, that is 7. So then first 15 will be charged as 2.74 per kilowatt hour, that means 15 into 2.75, and next 25 will be charged as 2.70, that's 2.70 into 25, and remaining 83 will be charged at 2.32. So 83 into 2.32, it comes out to be 308.16. Since there is a discount for 5%, so you just have to minus 5% or multiply by 0.95. The total bill that has to be paid to the utility by the consumer is 292.76 rupees. That's how this is also a block meter tariff. It also includes it actually includes only a fixed charge and unit energy. It does not charge the customer, it has not charged the customer as per the maximum demand. Now the second one, an industrial undertaking has connected load of 100 kilowatts. This is the connected load. So the maximum demand is 80 kilowatt. So on an average, each machine works for 60% time. So you can see that at your house also, then the connected load, you know that you are connected load to your house, but all the load will not be connected simultaneously at any time. That's why on an average 60%, it has been estimated over here in this problem that 60% of the time these machines are running. Find the yearly expenditure on the electricity if the tariff is rupees 6,000. Since it is not per something, that means it's a fixed charge. Rupees 700 per kilowatt of maximum demand. This is, we can see CX, this is F, and rupees 1.80 per kilowatt hour. This will be Y. So we'll first calculate the total energy consumption in year. That is, we have to calculate this D. That will be equal to this 100 kilowatt. Since it is used for 60%, that's 0.6 multiplied by total hours in 1 year. These are the total number of hours in 1 year. That is 24 into 365. It comes out to be 8760. So total energy used in 1 year is, this is 5,25,600 kilowatt hours. So the total electricity bill will be equal to this 6,000 multiplied by this 80 multiplied by 7,000. That is this, and the total energy consumed, that is this. So it comes out to be 10 lakh 8,080 rupees. That's how this can be calculated. So this is a type of three-part tariff, or we can say Doherty type tariff. Now comes the equipment that are usually used to measure the energy at the utility side. Those equipments or those appliances is known as energy meters. We may have two types of energy meters. One is the single phase energy meter or three-phase energy meter. But as per the residual consumers, we'll be only having the single phase energy meter. These energy meters may be analog or digital. If it is analog, we'll be only measuring the kilowatt hour directly, and it is displayed on this type of the display. So it is the analog type, and the unit on this will be kilowatt hour. So this is the energy meter connection, that how it is used. It has actually 4 connections. So it is usually connected in series with the line in phase. So if this line is connected to this line is connected to this, it is both lines are disconnected in between, and then the live wire is connected to this portion, the neutral wire is connected to this portion. Here the output of the neutral wire is taken from this connection, and the live wire is taken from this connection. So it goes to the main line of the, we can say, house or home. So this is how this looks like, an energy meter looks like, and here this is how its connection is made. It's very simple. We may have a digital energy meter. I have shown you here a AC 3-phase 4-wire static kilowatt hour meter, or in general energy meter. So it is capable of measuring and displaying all the quantities that we require. In case of analog, only one quantity is measured and displayed, that is the kilowatt hour. You can see over here, it measures the current flowing through it. It measures voltage across its terminals, that is this. It measures the power factor of the circuit. It measures the real power of the load, reactive power of the load, apparent power of the load, energy consumed by the load, reactive energy of the load, and usually the charge are made on the energy in case of a household or residential load. As I have told you that flat demand rate is not used, straight meter rate is usually used in metropolitan cities, and proper energy meters are installed there as well. So let's come to the electricity bill, how an electricity bill looks like. This is actually a snapshot of an electricity bill. This is ABC, this is the name of the company, and it's the address. So this is for the billing, this is billing date, account number of the consumer, due date of the bill, because it has to be submitted before due date, otherwise there will be some extra charges. So due amount is $8,312.73. So This is another description, or we can say information which is related to this bill. So previous balance is this and previous payments is this on this date, already done. Description is payment received, and the payment receipt for the amount is the all amount. So new charge is 8,312.73. That is this. I will see how this new charge comes out to be 8,312. This is again a type of a three-part tariff. Okay, now you can see this is the meter number, and this is the date of it is shown as a service period, but here it means the billing period. So number of days is 31. So previous meter reading is this, current meter reading is difference is this is actually the wrong reading over here. Actually it should have been 23245. You will see in the next slide it has corrected this. And on peak demand is 500 kilowatt and off peak demand is 150 kilowatt. It means whenever there is a uh, peak demand on the utility, the peak uh, maximum demand of the utility is 500, consumer is 500 kilowatt. Whenever there is less demand of, or we can say least demand on the utility, the maximum demand of the consumer is 150 kilowatt, and maximum demand is usually calculated in 15 minutes of intervals. You can see it has given demand charges, that is 15-minute kilowatt, that is for this amount of time maximum demand is calculated. So what is the basic charge? The fixed fee, it is $23. Electricity consumption, as I have told you, that is 23245. Here it has a wrong figure, it is not like this. So it is 2324. When you multiply this, it comes out to be 3778.01. So this is F, this is, you can say, this is C, this is X. No, this is D, this is Y. Total energy consumption, this is the uh, unit charge of the energy. So on peak demand is 5,500, so its charge are $7.13 per kilowatt, and off peak demand is 150, it charges 4.94 dollar 4.94 per kilowatt. The only difference is that here in this bill there are two you can say maximum demands. So in our case there was only one. So it is one of the same thing. It varies from this country to country. They may have slightly different types of tariffs, but it is, we can say, the basic concept is the same. So there are two peaks. So for these two peaks, or we can say two maximum demands, it has two charges. So for on peak maximum demand, it is 500 and it is charges 7.13 per kilowatt. This is for 4.94 per kilowatt. When you multiply these two, it comes out to be this 3,565. When you multiply these two, it comes out to 741. There are other charges which again we haven't discussed in our tariff. As I told you, these things vary from country to country. This is one of the country's bill. I have taken it from the internet to show you. So delivery charge, it has charged this per kilowatt hour, it is 0.00619, and transmission charge it is 0.00266. So for this it comes at $143.89, it is $61. So when you add it up, it comes out to be $8,312.73. Similar bill, we have another bill. In this case, this is 19/6/2015 to 17/7/2015. The number of billing days is 28. So this is the, we can say, customer ID. Service agreement ID is this. Rate schedule is this. So in this case, you can see there are different types of kilowatt hours and they are charged differently. So for this 292.9, at this rate, it comes out to be 47, 87.87, it comes out to be 16, 205 point this, it comes out 56, and 114 point this multiplied with this, it comes 38. And total energy consumption tax is 0.2. The total bill comes to $159.16. So this is a type of a block meter rate. why the blocks are charged differently for different blocks. So this is one more electricity bill. So I stop over here. I think these things are clear to you. Thank you.